So for almost any question that you have using the KincoBuilder software, you can almost always find your answer in the help menu, specifically in the contents and index section. So let's say that we wanted to get a better knowledge of how the contacts and coils work and all the different settings. So when we go into these contact types, they list these 4 types here. And these are unknown. There's no description to them. You can't get help on these. This is a normally open. This is a normally closed. This is a normally closed instantaneous or immediate, and this is a normally open immediate contact. But where do we get more information about these? Where do we get information about the coils as well? There's a lot more of the coils. There's a normally open, normally closed, immediate, jump, label, next, reset. There's all these different types, but there's not a lot of information given on these. Well, where we can find information again is in the contents and index section, and most always you can find everything you need in chapter 6. So we go to chapter 6, there's bit logic. Here's the standard contact. So it says a normally open contact versus normally closed contact. So when the bit value is equal to 1, a normally open contact is closed and power flows past to the next element. And when the bit is equal to 0, a normally closed contact is closed and the power flows on to the next element. So what does that mean? It basically just means if this is open, this is open. If this is closed, this is closed. And it shows you here in this example, like, hey, when this is open, Q0.0 is low, this is high, this is low, this is low. And what's this mean? So this would mean if this is open, this is on. If this is closed, this is off. So these should be inverse. When this is off, this is on. When this is on, this is off. Then these operations, as you get further on, this would be if this is open, or if this is closed and this is open, then this is on. If this is closed or this is open, then this is on. So really just using logic in these bits and how we would normally execute those, or say, oh, if I have this and this is occurring, then I want this output. Or if this and this or this occurs, then I want those. Then what are the immediate contacts? Well, essentially they're the same thing, except these ones will execute outside of the purview of the scan cycle. So the PLC is going to be operating where it reads all of its elements, knows all its settings, and performs a scan cycle that goes network by network. But if you have an immediate contact, then it operates as an interrupt. So it operates as soon as that gets power, or as soon as that loses power. Then power is passed on or turned off to the next element. Typically those next elements are function blocks, and those are always associated with some sort of coil, right? So we have a coil of a set coil or reset coil, which means just turn off power, or null coil, right? So null coils indicate the end of a network. No instructions really going to operate there. We can use that in a lot of different function blocks. Like if you're doing a P jog motion or a P homing motion, typically those are going to null coils. Then if you have a set coil, it's saying when I am done with this contact and function, and that function has completed, pass power on to this coil, or reset the power flow. Say, hey, I no longer want power to this coil. Then again, there's more of the immediate coils. Again, this would exist if you had an immediate set or immediate contact, then you very likely want to have an immediate coil so that it can also operate outside of the scan cycle. That way you're not delayed or worrying or waiting for a scan cycle to occur when you want something that would be, an emergency shutoff switch. You don't want those to be delayed by the scan cycle in the PLC. Then you can have sets and resets where whether or not something has power applied to it, it will be set, or when you apply power to something else, then you want to reset that exact output. So this Q output could be set by something. Let's say you're running to a position, you say, oh, I want this to be triggered when I have this immediate switch, something that's not a throwing switch where it has a couple of state settings, but it's just like a push button. Say you want a push button to start the operation and a push button to end the operation. So that push button where it presses once is instantaneous and goes back to its standard state, spring reset. Then press that and it would start, and press another one that would end it. That way you don't have to have a push and pull switch to start and stop and kill operation. And that same thing you can do block resets. That would be anything that's anything that is back to back. So if you want to reset Q 0.1, 0.2, 0.3, or you want to set M1, 1.1, 1.2, and then you can use these block resets, but they have to be consecutive. They can't be, I want to set Q 0.1 and 0.3. Those have to be two separate sets that you can use. So if you did a block reset of Q 0.1 to 0.3, it would also set Q 0.2. If you don't want that to happen, then you can't use these block sets. But let's see, how could we use this and leverage it in just a simple project, right? So let's say we have our network here, and we have something like an input. Let's just say we have I 0.0, right? And that's just a quick, simple spring set, reset, and then just you want it to start. So after you have this power on switch, what we want to do is have something that's an emergency stop switch. So we're going to add another right contact here, and we're going to make this a normally closed, and we're going to call that I 0.4. So what this will do is be our emergency stop. Say there's something wrong and you have to hit a button and kill power to it, right? But we want the power to go to Q 0.0. So when we hit a switch here, we have something that's operating, and when power is applied to I 0.0, then the output Q 0.0 is going to be applied such that our I 0.4, our emergency stop flag, has not been hit. But the problem is that I 0.0 right here isn't a throw, is a single position. So if you press it, it's going to spring reset. So you have to either press and hold it and stand there. Well, what we can do is add a parallel contact right here, and we'll call that the same as our output, Q 0.0. So now, as soon as we get power to Q 0.0, its own output is going to power itself. You can kind of think of this left branch here as power, and this right side of the network as where you want your power to lead to. So this I 0.0, when it's first triggered, is going to allow power to come from this left side and pass through here such that this condition is true, that I 0.4 is not active because it's our emergency stop. And if we activate this and we're not in an emergency stop, then we'll let an output go. Once this output goes, this right here is going to allow power to keep flowing through because this is an either or. So this doesn't have to be active anymore. And what we could do is show you this by simulating. We're going to run continuously. Well, so we know I 0.4 is not active, so it's going to allow power here. And what happens is if I just very quickly on off, now it's still maintaining power to this Q 0.0, but I just had a very simple push button to start my cycle here. But what I can do is say, hey, there's something going wrong. Let's hit an emergency stop. It's emergency stop. And while the emergency stop is going, I can turn this on, and that Q 0.0 is not going to be getting any power. As soon as my emergency stop is lifted, I can cycle that real quick, and I'm back to that power. So I'm getting an output to my Q 0.0, and because Q 0.0 is outputting, it's allowing itself to stay on.